In this video, we're going to get started on where we actually pick up and hold the items. Now, what we're going to do is open up our skeleton first for our mannequin, and I'm going to try to give you a rough idea of the logic that we're going to put behind it. And of course, my right mouse button is messing up again. So my thoughts here are we take our head bone and we will add a socket to it, and that socket will be somewhere out in front of us. So it's always going to kind of take in the rotation of the head, so to speak. And what we're going to do to have the ability to look up and down is we are going to soon create our own way to actually bend our character over. So when we look down, we want the character's back, so kind of at the hips, as if you were to bend down and pick something up normally. So that's kind of what we're going to do for looking up and down, is add our own aim offset. So we can literally just look up and down. And as far as the head kind of turning, we might do some IK with the head looking left and right, so that way it follows along with the camera, but currently that's not too big of a deal. The main thing we want to focus on is just simply having the ability to look up and down based upon our actual rotation of A, the camera, and B, the mesh itself. So as you bend over, we want it to bend at the hip, kind of like so. Like that. So to begin, let's select our head bone, add a socket, and let's just give this a name of S underscore item attach and save it. So now we can go ahead and move this on out. I can click it. We'll just drag it out by, let's see, however many centimeters that is. So it'll be there for now. So this is the socket we want to have the item attached to. So S underscore item attach. Next up, we head over to our item.h. We have our interact function, which currently just prints out the item we are interacting with. Now we want to take in something, whether that be our actor or the mesh, that we can actually try to pick up the item with. Now, try to think about this for a little bit, because A, we want to replicate this, so that we can kind of deal with later. So let's look real quickly at our character.h or .cpp, go to our interact function. We go through, we call server interact, then goes through and calls interact, just like it calls interact here. So we are making it to the server. So what we can do is attach it just directly on the server to the socket. Now, as of right now, I don't know if there's anything we need to really do, so to speak, in terms of dealing with the actor itself. So what I'm going to do is I'm simply going to just pass in the actor for the time being to this interact function. So if we go to interactable interface, let's add in a parameter. So it's going to be a character, and just call it character. So that's going to be the parameter we take in. And of course, we have to add that to our interact function in our item, in which case we can just pass in this whenever we go to call it. So from here, we go to our item.cpp, we do a check. So if character, then we can attach it. So first off, we want to get the mesh. So we're just going to do character, get mesh, and from there we can also get the socket. So that's what we're going to kind of do. So we're going to attach this, attach to component, and then the component we want to attach it to is going to be the character, and then get our mesh. So we want to do the third person mesh as kind of our attachment point. Now that went through and included character.h. That should handle the mesh as well. So if not, well, we'll figure it out when we go to compile actually. And then takes in f attachment transform rules. We are going to snap to target, not including scale. And from here, actually we may want to change that. Now we'll leave it. And then we want to pass in the name of the socket. So f name, then whatever we called it inside the engine. So s underscore item attach, like so. And hopefully this should attach it. So I'm going to print out a log just to check. Let's call it attaching, like so. Now, as usual, we modified the header file. So let's close the engine, save it. and just simply recompile and launch it. Alrighty, let's reopen the skeletal mesh, and let's just see what happens. So we'll view the log. We are currently playing as the listen service. That's fine. We'll press F, and there, as you can see, it is attached to the head bone. It's not controlling whether or not we look up and down or anything like that. It's just right to the head. Now let's check on the client and see what happens. On the client, we press F. As you can see, we have an issue. So if we look over here on the client, as you can see, it's attached. But on the client, it is not. So currently, I want to look at the item as well that we made. There it is. I don't remember if we set this to replicate. No, we did not. So if we open up our item, we can go down here to replication. We're going to set it to replicate. Now let's try it. So there we go. Now, as you can see, it is attached on the client, just like so. So that was one of the flags that I forgot to set. So our item is being attached and it's replicating, just fine. So for the time being, because a item is just a temporary class that we're kind of using the test with, yeah, we'll go ahead and do it. So in the constructor of a item, let's do b replicates, and we're going to set that to equal true, just so this flag that we set, wherever in the world it went, right here, is true by default. So we have it attaching. So we can pick up, hold the item. We don't really have a way to drop it yet. And same thing, we have also another issue that we're going to encounter. So let's say I pick it up with the client. And then let's say I pick it up with the server. Well, server just stole it. So people were able to steal items from each other, and that I am not the most fond of. So we want to kind of try to, what's the word? Limit that or restrict that. So we're going to have a basic Boolean to check if the item is actually being held or not. If it is, we do not want the player to be able to pick it up. But yeah, so we have everything in place. Now here's the only problem. We don't have a way to drop it. So we need to be able to store the actor or the item that we're hitting. So currently we're using a class called aItem. So we're going to kind of store it in our character. And let's do this, and we'll do it above. So right here. So first off, we want this to be replicated to the client. So that way, any info we need to pull from it, we can. So uProperty, just make it replicated. And then we are simply going to do, well, we have to forward declare it, class aItem, and let's call it held item, like so. And then in the interact, let's go to server interact implementation. What we're going to do is right in here, assuming it, the interface passes, we're going to do held item equals it result dot get actor. Now we're going to have to end up casting this because, as you can see, a item is not really wanting to be converted to a actor. So let's cast it. So cast a item, or better, wait, what am I doing? Change this from a item to a actor. I'm being stupid here. And we can remove the forward declaration as well. I keep forgetting that we're using interfaces. So we can just leave it. So held item is now of the type a actor. So whenever we go to pick it up, we assign it, and we're going to make sure we do the same thing up here. So now we have access to held item. Now we need to make it so if we have, the item in our hand, we go through and drop it. So what we can do is on interact, we can have it call a function, and otherwise we can have it call a different function. So we're going to have one for pickup and one for drop. So let's do void pickup and void drop. Let's create the implementation for both of these, like so. And we're going to have a basic check to determine this. So if held item, we want to drop. Otherwise, we want to pick up. Am I spelling that wrong? Oh, pick up lowercase. There we go. So when we call pickup, we're essentially going to be doing this kind of what's going on right here. Now, the only difference is we want to kind of make this what do you call it? More modular, or I don't know if that's the right word, but we want to make it so we're not duplicating the same code. So pretty much the way we're doing this is, well, forget that this check right here exists. We're getting our start and end location for the line on the client. We perform the line trace, check if it hits anything and all that fun stuff with this function here that we made. And if it does hit something, we're going to do an authority check. So let's assume we're the client. So this else statement's going to run. So we call the server RPC and we pass in our start and end location for the line. Inside that server RPC, we do the exact same thing with the start and end location. And then we pretty much go through and cast it, blah, blah, blah. So what we're going to do is in pickup, we can make it, well, let me rephrase that. We can make it so we combine the two functions, so to speak. So that way we just call pickup either way, and it's not going to matter. So that way we only have one portion of the code that we have to change. So for the time being, let's just copy this fun stuff in there, and we'll go from there. Okay, so we call pickup. Now, how can we make it so it shares with the server? Because right now the server takes in a start and end location. And if we wanted to call pickup again on the server, we would again be using, well, we would be using the server's version of the start and end. So what we can do is make pickup take in the start and end location, just like our server RPC. So server interact takes in 2f vectors. Let's pass those in. And I just realized I don't know why I'm calling this camera end. So let's change this to line start and line end, like so. Let's rename these. Actually, we have to modify it first. So there's our pickup. And let's rename our server interact as well. That way it's a little clearer. Here it is. In which case we're going to have to change the names like camera start and camera end, like so. And that's all. So then we just pass it into pickup. So what we're going to do is copy our start and end that we get and pass that right into pickup. In which case all we do is perform line trace. We change it to start and end, just like so. So now on the server, we're pretty much going to do the same thing. So we perform the exact same thing like before. So we just literally do a straight call right back to pickup. So pickup, line start, and line end. And that's it. So it's going to recall it. So to quickly step through what we just did, when we call interact, if there's an item in hand, we obviously want to drop it. If there's not an item in our hand, we want to pick it up. So we're going to get our start, so pretty much our camera's location, so the place where we want the line to start, as well as the place where we want the line to end on the client, so that way it's accurate, in which case we call pickup. And we pass in, obviously, our start and end. Then we go through, again, this is on the client, check if the line trace hit something. If it did, obviously we print out, but then we're going to check if we're the server. If we're the server, we go ahead and we call the interact function. Because we have authority, it doesn't matter. But if we're not, which would be in our case, like we're assuming, means we're the client, we call the server RPC and pass in the line start and line end. So we now make our way to the server, in which case on the server, we call pickup while passing in the same line start and line end. So the positions are going to be the exact same. And from there, check if the line trace hit something, which it should be true anyways. We check if we have authority, in which case we will this time because, again, we are the server now. And then we call interact. So we go from the client to the server all this way, and now we only have to worry about this function, pickup, where we have to change something in regards to actually picking up an item. So hopefully that was relatively kind of simple to explain, or understand anyways. And that's it. So now let's go ahead and confirm that this is working. So I'm going to close down the editor and relaunch it. And it just occurred to me that we are not replicating our held item. So let's create that replication function. So what was it? Out rep. What is it? Search for lifetime and it comes up. Yeah, get lifetime replicated props. as always, I always forget. So virtual void get lifetime replicated props, takes in a T array. You can literally pause and see right there. Create the implementation. Make sure you call super. And then we can do rep lifetime. We're going to take in the class, so a escape room character. And then the variable, which in our case was held item. So obviously it's going to complain, so we need to include up at the top net Unreal Network. So that way we can include and set up our replication that way. So now our held item is replicated. So again, let's run one more time and make sure everything works. Okay. Yeah, why not open it? Let's just make sure, nothing's obviously broken. We press F, pick it up that way, do it on the client, and we pick it up that way. So we are good to go. We have everything set up, and it's now combined into one pickup function. And same thing goes, we're actually holding the item. So in the next video, we're going to go ahead and implement the drop portion of it. So that way we can, drop it. Anyhow, that'll be done in the next video. So that's going to be all for this one. If you like what I'm doing and you want to help support me, feel free to check out my Patreon that's linked in the description below, where I have a Patreon-only Team Deathmatch course where we use Unreal Engine with C++ to create Team Deathmatch from the ground up. Have a bunch of other interesting features in there, like weapon customization, fancy spawning, and all that kind of stuff. If you have any questions or anything like that, feel free to join my Discord that's also down below, and I'll try to help you out. So, take care.